So order of a matrix. Is generally given I by J. It's written as, you have to read this as I by J. Okay. So I is number of rows and J is number of columns. So that's the first definition we have with order. It can be m by n or whatever. So many rows, so many columns. Then broadly, the types of matrices what we have. Types of matrices. I'll put this so that I'll have a time displayed here. 1 by 530, isn't it? Okay. So it's a 451. Types of matrices. It's very simple. That means we can say even m by n also, as I said, right? This can be m by n matrix. So if the number of columns equal to 1, then matrix is called column matrix. Column matrix. So similarly, if the number of rows equal to 1, then it's a row matrix. Square matrix, if the number of rows equal to the number of columns, if number of rows equal to number of columns, so a matrix in which the number of rows are equal to the number of columns is said to be square matrix. Okay, but then you won't actually have 1 1. Okay, so the number of, that means then it is called a square matrix. Okay, so these are the major types of matrices, but then you have some more special cases. Whatever I am talking now, the special types, these are candidates for 1 mark questions. Column matrix and all they may not ask, but this they will definitely ask. Diagonal matrix. So diagonal matrix meaning is said to be diagonal if all its non-diagonal elements are 0. Okay, what are the non-diagonal elements? Okay, so in this case one important thing is there is only one diagonal. We don't have a two diagonals, and that's called actually principal diagonal. Left top to right bottom. That means you have, for example, a rectangle. This is the diagonal. That's what they talk about diagonal. Okay, so you have a matrix and this is some x and this is 0 0 0 0 0 and 0 0 0 whatever, and next y 0 0 0 0, then comes like this, for example 0 0 0. Then you have, for example, c 0 should be diagonal, right? So I should not have anything. The moment 0 comes here, it can't be. Therefore, I'll remove all this stuff. Okay, and I'll take 3 by 3 matrix, for example. This is 4 elements I have written. I'll take 3 by 3. So 0 0 z. This is the diagonal. So this diagonal is non-zero. Diagonal non-zero. Okay. Scalar matrix. Diagonal matrix is a scalar matrix if xyz is equal. So scalar matrix is a diagonal matrix where x equal to y equal to z is not equal to 0. So definitely some number should be there. Example will be example. So you can have 1, 1, 1. Okay, or it can be 7, 7, 7. So they must be equal. So these are the examples of scalar matrix. Identity matrix is this one. Identity matrix is a scalar matrix it is a scalar matrix in which the diagonal elements equal to 1. So this is the one. So you can have 1 0 0 0, for example, 0 1 0 0, 0 0 1 0, and I'm taking the 4 by 4 matrix 0 0 0 1. So this is also identity matrix, this is also identity matrix, both are identity matrix. Then yeah, the diagonal is 1. This is the diagonal which is 1. Okay, 0 matrix is the simplest. The entire each element is 0. 0 matrix. So each element is 0. Each and every element is 0. That's a 0 matrix. Okay, so these are all the additional types, and they will generally give 1 mark question. Many times scalar matrix is given. Okay, scalar matrix 2 times they gave. Equality of matrices. Yeah, what do we mean by definition 2? I am on page number 63. Two matrices A, B said to be equal if they are of the same order and if each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij. So the definition, if you read the definition there, equal matrices. So let's say A be a matrix of m by n order, and let P be a matrix of p by q order. A is equal to B if m equal to p and n equal to q. That's number 1, first condition. Then the second condition is you pick up any element of I by j. That means I will be go from 1 to m. Okay, in this case 1 to m. J will be 1 to n. That means 1, 2, 3, 4, 5, 6 up to m, like that. Okay, is equal to, I will explain this part with an example. B ij, I will be going to 1 to p and j will be going to 1 to q. So let's consider A is equal to 1, 2, 3, 4, 5, 6, 7, 8. Since it's an example, I have to take same thing. 1, 2, 3, 4, 5, 6, 7, 8. So the order of A equal to 2 rows and 1, 2, 3, 4 columns. Order of B is also 2 rows and 4 columns. Now I am taking A 1 1. Okay, normally when we take, actually one correction, when we take this Aij, they use a small capital letter. Aij, they use a small letter. They will just say Aij should be equal to Bij. B for the small letter. Therefore here also, now if I, so A1 1, that means first row, first column. So if I say row like that, and this is the column like this, then this is that. So A11 is 1. So B11 is also 1. And I take now randomly another one, 2 4. That means second row, fourth column. This is the second row, fourth column. That means this equal to 8. Here B24 is also 8. Therefore they are equal. Obviously you won't get this silly stupid question in the exam. Check whether these matrices are equal or not. Okay, you won't get that, but you get, they will just say matrix X, question, matrix X equal to matrix Y, X equal to 1 5 6 20, Y equal to A 2, sorry, not 2, A 5 6 B. Find AB. They can also give find AB, or they can also say find A plus B. Okay, so since X and Y are equal, the corresponding element should be equal. Therefore 1 and 20 equal to B. So this is how you will get a 1 mark. Okay, so that's about the equality of matrices. So we are now going to the exercise 3.1. So the first question, number 1, in the matrix A, write the order of the matrix. You are there, right? Page number 64. Page number 64. It's exercise 3.1. So the order of the matrix is, there are 1 2 3 rows, 4 columns, by 4, 3 by 4. The second one is, how many number of elements are there? Whatever you merge to, right, that is the number of elements. Number of elements equal to 12. Third one, write the elements A13, A21. So he is asking 3. First row, third column, 19. Can you tell me the next one? A21. $35. Okay, good. Then the next one is A33, third row, third column, -5, isn't it? Then the next one is A24, fourth column, second row, fourth column, is 12. And the last one is second row, third column, 5 by 2. So those are the answers for the first one. Second question, if a matrix has 24 elements, what are the possible orders it can have? It's simply getting the factors. Okay, that means 24 elements are there. So it's a factors, like it can be 1 into 24, 1 by 24 or 24 by 1. It can be 2 by 12 or 12 by 2, or it can be 3 by 8 or 8 by 3. It can be 4 by 6 or 6 by 4. That's all, right? No other factors. So these are all the possible orders for that matrix. So what are the possible orders? That's the answer. What if it has got 13 elements? So 13 elements, only two possible. It can be 1 row 13 columns or 13 rows 1 column. That's it. So two orders are possible. Okay. Third question, if a matrix has 18 elements, what are the possible orders it can have? Can you tell me? Same factors of 18 you should tell me.
1, 2. Question, sir.
Question 3.
Yeah, 1 into 18.
Yeah. 18 into 1. Second 2 into 9.
8 into 6.
3 into 6. 6 into 3. That's all, right? That's all. Okay. 6 possibilities. If it has 5 elements, then 1 into 5 and 5 into 1. Okay. Fourth question, construct 2 by 2 matrix A equal to Ij whose elements are given by this. Okay. I'll do the third one. Okay. You do the 1 and 2. Okay. Fourth, third I will do. So the other one is if it has got 5, let me complete this.
Second is easy, no? Ij 1 by 2, 2 by 1, 2 by 2. Isn't it? That's why I skipped it. Now go to the fifth one. Anything. You can do one also, you can do whichever. I think fifth one only, first one maybe, not the second one.
Done. So A21 is 5 by 2.
Yes, sir.
So okay, so you have done completed, right? Now you can go to the sixth question. I won't do it because it's very easy. Sixth question. Find the values of x and y and z from the following equations. So left side is a matrix, right side is a matrix. So you will be comparing x equal to 1, y equal to 4, z equal to 3. Second one, you have simultaneous equations. X plus y is equal to 6, xy is equal to 8. So I will do that part. Okay. So it's a sixth question. Second part. X plus y is equal to 6. Xy is equal to 8. And how do we do this? So we will just say y is equal to here, y is equal to 8 by x. So you get a quadratic. Plus 8 by x equal to 6. I substitute into this, right? So x squared plus 8 equal to 6x. So x squared minus 6x plus 8 equal to 0. So x equal to 4, x equal to 2, because x minus 4 into x minus 2 equal to 0, so you will get x equal to 2. So when x equal to 4, y is equal to 2. When x equal to 2, y is equal to 4. So these values we have got. The next one is 5 plus z equal to 5. That means z equal to 0. So it is 0. So you have either 4, 2, 0 or 2, 4, 0 are the xyz values. This is the answer. So next one is a simultaneous equation. You have to solve it. X plus z equal to 5, y plus z equal to this. So let's look at third sum. X plus y plus z equal to 9. Then you have x plus z equal to 5, y plus z equal to 7. So add these two, you add them, you will get x plus y plus 2z equal to 12. Now work with this and this. So subtract, this is 2 and this is, that's 1 and this is 2. Do 2 minus 1. So you will get x plus y plus 2z equal to 12 and x plus y plus z equal to 9. So subtract it. So this minus, this minus, this minus. So this gets cancelled, this gets cancelled. You will have z equal to 12 minus 9, which is 3. So you got a z value. Substitute that. So x z equal to 5. X plus z equal to 5. That means x plus 3 equal to 5. So x equal to 2. So you got x equal to 2, you got z equal to 3. You can substitute in the first one if you want. Then you get 2 plus y plus 3 equal to 9. So y is equal to 4. So the seventh one is find value of a, b, c and d from that equation. Okay. So that's easy one. You can do it. Okay. Make it maybe as a homework. Very easy. Similar to sixth one. Now we have 8th, 9th and 10th. These are the 1 mark short questions. Okay. 8th question is, it is a square matrix and he is giving the order is m by n. If it is a square matrix, number of rows must be equal to number of columns. Therefore C is the correct option. 9th question, which of the given values of x and y make the following pair of matrices equal? Okay. So you can go forward. When you do forward, there is a PUC style. That means when you want to do long questions, you go backward. Backward means you do the substitution. Substitute a values, substitute c values, substitute d values, like that. Then you get the correct answer. So this is called a CET style. When you are doing competitive exams and all, you will do backward. Okay, you substitute, you don't do the forward. Okay. So but I am doing the forward. I am checking with a first. So x equal to minus 1 by 3, 3 into minus 1 by 3, you will have minus 1, minus 1 plus 7 equal to 6. So 6 is not equal to 0 and therefore A is not the correct answer. I will take the second one for example. Second one is minus 2 by 3. So minus 2 by 3 will make 7 minus 2, which is equal to 5. That's also not possible. Okay. So D, when I take D, x equal to minus 1 by 3, also not working. When I substitute x, that should become 0, right? 3x plus 7 should become 0. So not possible to find is the correct answer. So B. 10th one, the number of all possible matrices of order 3 by 3 with each entry 0 or 1 is how much? Okay. So the maximum number, why, see 3 by 3 meaning you will have totally 3 3s are 9. You will have 9 values. So 9 values, when you look at the 9 values, the way this is done, what is your fourth one? Is it computer science or electronics? Your fourth optional subject? Computers. Okay. So if you have, for example, 9 possibilities, that means totally 9 values will be there. It is something like if you have 1 byte, right? 1 2 3 4 5 6 7 8 9. So it can be 0 or 1, 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 it can be 0, like that. So how many places are there? Totally 9 places are. So you have 2 to the power of 9 values totally you will get by toggling them. 2 to the power of is 256, 2 to the power of 9 is 512. So the answer is 512. So why they give this kind of a question? Because it's easy for electronics and computer science people to imagine that, okay, this is 1 bit more than a byte. A byte is 8 bits. Okay, so one byte you will have 256 possibilities, you will have 512 possibilities. That's what is the question. Okay, so we do have 7 more minutes, and of course I won't start the operations on matrices. Anyway, the operations are the plus, minus, then you will have the multiplication. There is no division of matrices. Okay, so these are the things which we will be talking in the next class. Complete next exercise will be done. Okay, so you have learnt the multiplication, and all the questions relevant in exercise 3.2 are taught already in ICSE style. Okay, only 3.5, the next exercise, which is 3.3, where you will have a transpose of a matrix. That is the one which you have not learnt in 10th. Okay, so that's the one specific to, and you will have questions coming from the 3.3. So 3.3 we may start next class. I think we will be completing 3.2 also very fast, and after that we will have an elementary operation, the most hated. That means some people don't like that. Okay, and a question comes from that exercise. 3.4 and 3.3 guaranteed questions. Okay, exercise 3.3 and 3.4 questions guaranteed in. Okay, so there is one thing, I mean, I'm just now filling the next 5 minutes with a useful discussion than the matrices chapter. Okay, so in any subject, basically, there is easy topic will be there, and there will be difficult topic also will be there. Sometimes as a student, what we do, we'll try to just prepare because it's easy topic, and we leave the difficult topics. Okay, but sometimes the examiners may think, right, they may give a difficult question in easy topic, an easy question in a difficult topic. Got it, right? Therefore, your strategy should be, as a student's strategy should be, even if you learn easy topic, don't drop the difficult topic. So finish all the easy questions in the difficult topic also. Understood, right? So then you will get a chance of actually answering both types. Okay, so difficult and difficult. If it's a difficult question in the difficult topic, okay, in case you have not prepared, that's fine. Okay, but of course I am not teaching you that okay, you can leave some topics, or but this is what you will be hearing from your friends. They'll say no, I am preparing only this. The other elementary type also it will be very difficult. Let us skip that. Okay, but the method is difficult in the elementary operation, but they give easy question. Understood? No, they get generally easy question. Okay, even in the last 2 days before, you can learn that. 2 days before the examination, right? Even if it is confusing up to that point, and just you have an examination in the next 2 days, if you want to get marks, full marks, even at that time you can learn that elementary operations. It's a bit confusing, but you can definitely do. Okay, so that's why the next 3.2 is okay, kind of very less marks question. The 3.3 and the 3.4 guaranteed to have a good questions, board questions. Okay, so what is that they are covering in the school now? Differentiation.
They're doing inverse trigonometry.
Is it so easy for you now, or still difficult?
Easy, sir.
Easy. Very good. Good to hear that actually. Okay, so I am now stopping the first of all recording.